All right, so anybody watching this at home, this is not part of your packet, but this is up on Classroom. All right, these additional notes. All right, so I'm going to start with the first one I want to do with you. We are going to be proving a lot of triangles congruent. So first thing I want to do with you is let's go through those 5 methods right now, so we don't have to review it every single time here. What are the 5 ways we have to prove triangles congruent? Via 1. Angle, side. Zach, 2. HL. That's only in for a what triangle, though? Right triangle. If it's not a right triangle, don't even try to use it. Even if it is a right triangle, it may not still be HL. 2 down. Emma? Side. Luke? Side angle, side. And then I have what happens if the side's not in between, or if it's in between. Angle, side angle if it's in between. All right, so there are 5 methods of proving them congruent. All right, let's do this. Prove PS congruent to PT. What are PS and PT, by the way? Those are what in the circle? Those are secants. They're not automatically congruent. Tangents are, but not secants when they're drawn outside. So we need to get them congruent, and probably the only way we can get them congruent is to do what about the triangles? Prove them congruent so we can say what at the end? C, PCTC. So that's my goal right now. So we got our givens. I feel like it's been forever since we've done a bunch of these. All right, I need your help. I need a pair of sides, a pair of angles, something that will get these triangles congruent. All right. Again, it can be something related to the circle unit, or it can be anything all year. All right. Circle facts alone are not going to get the job done. We're going to have to break out some old stuff. So any sides or angles you want to start with here? You got to be able to start with something. 2, start us off with something. Yep. Good old reflexive we can rely on, right? PR congruent to itself. All right, we got a side down. I'll just do what I used to do in the past. I'll put a little S next to that. We got a side. Mark it with an X. There. Anything else we want to put in here, Zach?
That PRT and PRS are the word's not coming to my head. The right angles.
Thank you. Yes, the right angles. Everyone see that perpendicular lines? They form right angles. So I haven't done anything with the circle yet. This is all review. So angle PRS and angle PRT are right angles. Anybody remember the reason? Perpendicular lines form right angles, like we never left, right? And then usually we said, very next step, don't forget, say they are now congruent. Yep. Now they say they're right angles, say they're congruent. So angle PRS congruent to PRT. All right angles congruent. So you guys have gotten away right so far without using any circle facts until now. Until now, right? I need one more pair of angles or sides that are congruent to get the triangles congruent. And you're almost there. Carter, see something?
Isn't SR congruent to RT?
How do we get there? It will be in a couple steps, but I need a circle fact to get there. This is why we had to do this review day. What's up, Molly? Radius drawn. Okay, everyone see QR? That's a radius. If I have a radius perpendicular to a chord, it does what to the chord? Bisects it. Yes, so what we can say here, I'm not going to say those two pieces are equal, but I'm going to tell you ST is being bisected. So I'm going to say QR bisects ST. This is a circle fact we needed. Here's the fact. Again, radius, you can write diameter too. Radius perpendicular to a chord does what? Bisects the chord. Yep. Perfect. Then you can tell me what Carter just explained, that SR is indeed congruent to RT. What's your reason here? No circle fact. Yep, definition of bisects. And I think you guys can go ahead and finish it. I'm running out of room, as you can see. You can go ahead and finish it. What's the only thing I'm going to ask somebody, what's the method going to be now, why those triangles are congruent? What's the method here? 3. Yep, side angle side, and then last step should be CPCTC. Look good? Any questions there? So yeah, you're going to have to use some review reasons and some circle reasons. Combination of both. All right, next one I want to go to, and sorry I didn't number these. The 4th one here. Again, anything we don't do is on you for the weekend. I chose this one because it's got a reason that we haven't used, and I couldn't even tell you how long. I just want to make sure it's you guys know it's out there and remember it. Okay, in the givens, NOG, make sure you know it's that's NOG right there, POG right there. So those two angles. And everyone see the angles I need congruent. NRO and PRO. All right, so what am I going to have to do first then? Prove the triangles are congruent again. This is another CPCTC one. Just get the triangles congruent. You could say CPCTC. All right, I need your help though. Give me a side angle you want that you know eventually will be equal to the angles.
Yeah, maybe.
Okay, they are, but I have to include a step first. All right, and Molly just went right for the throat real quick. She went for the one we haven't done in a while. Yes, the ones next to these are equal, but it's a 2-step process to get them equal. What do you know about these two that are right next to each other? They are supplementary. So I need to say they're supplementary first before saying they're congruent. So I'm going to take angle NOG, the one from the givens, and the one right next to it, which is NOR, and say they're supplementary. And then tell me the other pair is supplementary too in the same step, GOP or POG, and the one right next to it, POR. But do you know why we know they're supplementary? No circle facts here, Addy. That's next. That's you're telling me why they're congruent. I need to know why they're supplementary. Supplements of congruent angles is what we're going to say those angles are congruent. But why do we know they're supplementary, Romeo, remember?
Linear pairs are supplementary.
Because they're linear pairs. Good. Linear pairs are supplementary. Then you could say the two angles inside the triangle are congruent. But it's a 2-step process. Tell me they're supplementary, and then tell me they're congruent. Molly just went after it right away there. Thought that was going to give me a good old reflexive, but You're better than that, right? Or just wanted to show off? This is supplements of congruent angles or congruent. Remember that one? Used to be up there in what, yellow paper? I used to have them up on the board. Oh, the good old days, right? Whew, all right, now that should be hopefully clear sailing. I got a pair of angles. What else do you know is congruent here? I need some more sides or angles from you guys, whether you use a circle fact or not. 11.
OR. Congruent to OR.
All right, that guy. Somebody had to say it though, right? And just a little hint here, right? I haven't used the circle fact yet. Might be time to use one now, right? Might be time to use one. And I am going to call on somebody for this one because this is something we should see. 5, anything? Not here. 15. Anything you see in the circle?
O N and O P.
There you go. Got it. Everybody, we got ON congruent to OP. What are those? They're radii, right? And we know in a circle, got to start it off with that. In a circle, all radii congruent. Good job. Good job. That was the big circle fact for this one. All right, I'm not going to finish it. You guys finish it right now. What's the method for the triangles? 6, method for the triangles being congruent. Side angle side, and then you guys go ahead, finish it. CPCTC. Feeling all right? Gonna go to the very next one when you're ready. The very next one. And I will apologize. Sorry how unprofessional this whole packet looks. I won't lie over break. I just literally cut and pasted from a couple websites and threw them on a Google Doc. So there you go. I didn't have the patience to format everything so it looked nice and pretty. So this is what it is. All right, a couple things, just so there's no confusion here, and this is why I probably, especially for this one, I should have formatted it. Arc WY, that's arc WXY. Okay, I'll actually write that in the givens. When it says arc WX, we're talking about arc WY, that's arc WXY, is congruent to, when it says XZ, that means XYZ. That's the arcs they're talking about. And I know it looks a little sketchy. I want to know the chords. These are line segments above, not arcs. I want to know the chords are congruent. All right. Well, when are the chords going to be congruent? When they're what are congruent? Chords are congruent if the arcs are congruent. So is there any way you can get arc WX congruent to arc YZ if I told you these two here were congruent to each other? Can I get arc WX and arc YZ congruent so I can say the chords are equal? That's my goal. And some of you guys may be thinking about something, but you're like, I don't know if I can do that with arcs. And the answer is yes, you can do that with arcs. And it's been a while, I know, but yes, you can do. Same thing we did with angles and segments. You can do with arcs. Way back in the day when it used to be up here. Via got a thought?
Yeah, you can, how do we say it? You can say that the angle XWZ, is I don't know how to say it.
I don't want to don't involve other angles. I want to stay with the arcs. Okay, I want to stay with the arc so I can get arc XW and arc YZ congruent so I could say the chords. Luke, got something?
Can you subtract arc x, y?
You can subtract. You can subtract and add arcs. Everyone remember doing subtraction and addition? You need how many pairs of equal quantities? I feel like I ask that like 5 times a day. 2 pair, but I only have 1 pair up here. What are you going to subtract from each of these 2 given arcs? XY. Everyone see that? You're going to subtract XY. So the first thing I'm going to have you put down is, hey, XY and XY are both the same because of reflexive, yeah. So you can add and subtract arcs. Now tell me what you're going to subtract. WXY minus XY is the same as doing XYZ minus XY. That's subtraction. And I felt like I did this 5 times a day as well. What's always after subtraction or addition? Substitution, right? To say the arcs we want are congruent. So substitution now, if you subtract those arcs, you get WX and the ones we wanted, YZ. And if the arcs are congruent, so are their chords. And my reason, here you go, ready? Here's your reason. Congruent, what do I have right now? Congruent arcs, and you can do the arrow, imply congruent chords. Ooh, I did. Supplements of congruent angles are congruent, addition, subtraction. I feel like we're back in October. Anything? All right. Next one I want to go over with you. Yeah, there you go. The one that looks like that. All right. Real quickly, I know this sounds silly, but one reason why I'm doing this with you, I'm not saying it has 5 steps. Okay? It might have 7. It might have 3. All right, don't assume 5 here. All right, so that's one reason why I went, because you'll see that in a couple others. Because you'll remember I was just not feeling the formatting here. All right, chord AB, congruent to chord CD. Get me arc CA and arc BD. And you just can't say the chords are equal, so the arcs, because they don't belong to those arcs. So AC and BD, give me them congruent. Take a little hint from the last proof we did, right? Well, if those chords are congruent, what arcs have to be congruent then? Name the 2 chords that have to be, the 2 arcs that have to be congruent. All right, here we go. 11. AB belongs to what arc?
ACB.
ACB. Use 3 letters here for me, all right? ACB congruent to, what's CD belong to?
CBD.
CBD. Yep. How would you write this one now? Congruent chords now, right? Because now I'm given congruent chords. Imply congruent arcs. Now do you guys see how I'm going to get the smaller ones equal? All right, I got this one here and this one here equal to each other. I just want an explanation, then I'll let you write it on your own. How are you going to get AC and BD, those arcs equal now? 6, little talk. Hi, Luke.
Subtract CB.
Okay, so put CB congruent to CB first, arc CB congruent to arc CB, subtract, substitute. So you guys have 3 more steps remaining now. Tell me arc CB is congruent to itself. So I guess it was 5 steps, huh? Coincidence. Any issues, questions? Go ahead, finish that up, you guys. I think we got one more I want to do with you. I might be lying. I have 2 more. All set? Boom, next page. I think you can tell why I want to do this one with you. And now what do I need to prove? Triangles not congruent. Similar. What's the main way we're going to go here? Okay, you guys got to help me out then. I need 2 pairs of angles from you then that are congruent in this diagram because I didn't give you any. I need 2 pairs of angles that are congruent. So I got all my givens. Ooh, T is the midpoint of arc CD. And BT is a tangent. Okay, let me first start with T's the midpoint of arc CD. Name 2 arcs that are congruent then. If T's the midpoint, give me 2 arcs that are congruent. 9.
CT and TB.
CT, congruent to TB, or TD, excuse me. Definition of a midpoint. I know I'm gonna. Hey, they wouldn't have gave it to me if I'm not gonna need. If I'm, gonna use it or not. Definitely gave it to me for a reason. All right, I need your help. I need 2 pairs of congruent angles somewhere in that diagram from those 2 triangles, and they're probably going to be both circle facts. Okay, take a look. Look at the angles inside both triangles. How could I get 2 of them to be congruent to each other using some kind of circle fact? Look at all the angles, everyone. Look at all the angles. Try to match them up too. Oh, it's got to be this one and this one, but how can I get them congruent? Via, you want to start with 1?
Sure. You can say angle CAT is congruent to TAT.
Okay, let me start with that pair. I like it. Hey, this is where V is going. These 2 up top are equal. Absolutely correct. Angle CAT congruent to BAT. It's true. Just need the Y. What type of angles are they? Inscribed angles. And they're both drawn to 2 arcs that we already wrote down that are what? Congruent arcs imply what? In this case, not chords here, but what did you write down? Congruent arcs imply congruent. Don't write angles though. That's not true. They got to be a special type. Congruent inscribed angles. Yep. All right, so thanks to Via, we got a pair of angles. Need another pair. This is the tougher pair. What other two angles up here are going to be equal? What's up, Zach?
ACT.
Okay, stop right there. Everyone look at ACT. Anything we should know about it? It's inscribed. And where's it drawn to? Diameter. Makes that what type of angle? Okay, so ready? Angle ACT is a right angle. Reason? Inscribed angles drawn to a diameter or right angles. Good. Which means, what else has to be in the other triangle? A right angle. So where is that? You may be able to tell just by looks, but you can tell me why that thing's a right angle. So let's just get it out of the way. We know it's going to be ATB. Either because you know the circle fact or just because it looks like it, right? So angle ATB is a right angle. But, you know, you can't write because it looks like it. I need a circle fact that's different from inscribed angle because it's not an inscribed angle. Why? How did I know that was going to be a right angle? Addie, go ahead.
Is it a radius drawn to a tangent?
It forms a right angle. Everyone remember that one? If I have a radius, OT, drawn to the point of tangency, it forms a right angle. There you go. Radius drawn to the point of tangency forms a right angle. And I'm doing these proofs. I'm picking certain ones because I want to get through as many circle facts as I can for you this weekend. Radius drawn to a point of tangency forms a right angle. Who's on top of their game? Can I say they're similar in the next step now? Are these triangles similar? What method did you tell me? By what method were we going to prove these similar? Angle, angle. You only have angle, don't you? You only have one A. Where's your other A we haven't written down yet? I got to tell you those right angles are equal. Yeah. I know we wrote them down, but I still need to tell you they're equal to get that other A. ACT congruent to ATB. All right angles congruent. And now you can say they're similar. Angle, angle. And there's one more I want to do with you, and then you're on your own. And I think that's the very last proof. And again, not necessarily 8 steps. All right, we're gonna do this as a group now. I'm not gonna push you anywhere. Give me something that's true. You can start with the given. The midpoint is CD. It's up to you because we're gonna have to prove the triangles congruent. Let's get that out of the way. This is a prove a triangle that goes CP CTC. All right, tell me something. Anything you want to tell me. 17.
Arc CA is congruent to arc AD.
Good. All right. CA and AD. All right. Make sure you don't get confused there. It says A is the midpoint of CD. CD, right? So let's see. Arc CA is congruent to arc AD. Definition of a midpoint. Got it? I like it. Anything else? Remember, we're trying to get the triangles congruent. So anything you want to tell me? 11? On fire today.
Arc AC, CD are supplementary, and arc AD and DB are supplementary.
Where are you going with that?
You would, since you have congruent arcs, two congruent arcs, it would imply the other two are congruent.
So you're trying to get CB and BD equal, correct? All right, does everyone see where Zach's going there? He wants to say, well, first of all, this is a diameter. So what do I know about this half? 180, what do I know about this half? Because it's a semicircle, right? So we could throw that down that, hey, arc ACB equals 180. And on the other side, arc ADB equals 180. And how do I know they equal 180? Good, you can write, yeah, definition of a semicircle. What do you have to do, though, to get CB and BD equal, though? What do I have to do with those semicircles and these arcs? Because Zach's like, hey, I want to try to get CB and BD equal. What am I going to have to do to get them equal then? What do I have to do with the semicircles and these two arcs to get CB and BD to be equal? Emma, I got to subtract them. Okay, everyone agrees? I got to subtract them. So show me you're going to subtract them. I know I'm not staying within my numbers here. So ACB minus AC, good, is the same as ADB minus AD. Subtraction. And what's going to go next? Substitution. To say CB, the arcs, not the chords, congruent to BD. All right, remember, we have been talking about arcs this entire time. Nobody said anything about the sides or angles yet. Right? Nobody said anything, but now I think you can confidently say something about the sides or angles. Give me a pair that are equal for anything.
ACB is congruent to ADB.
Well, go ahead, tell me.
They're both drawn to the diameter, so they're right angles.
Okay, so I got to say the right angles first, and then I'll say they're congruent. Everyone all right with that method? All right, because you can't just say they're equal yet before you got to tell me the right angles. Yep. So angle C and angle D are right angles. And we just used this theorem in the last proof, which was inscribed angles drawn to a diameter are right angles. Yes, Romeo.
Didn't we already just prove the two?
Yeah.
Since we just proved the arcs congruent, we can just say CB and BD are congruent because congruent arcs.
Okay, you got me there. Congruent arcs imply congruent inscribed angles. You can do that too. Yeah, that's fine. I'm just going to keep going with mine too here. That's fine. Yep, that's fine. I got you there. All right angles congruent. Good, fine. Good call. Is that what you're trying to tell me, Molly? Sorry. All right, what else is congruent here? What else you got for me? There's a lot of different ways we could take this proof now. You got the right angles or beat C and D. What else is congruent? Go ahead. Via, go.
It's not line CV. Oh, sorry, chord CV is equal to DB.
Chords, yep. CB and DB, those line segments are equal because congruent arcs imply congruent chords. So I got the right angles and I have CB and BD. Anything else congruent? You could look, I'll get it out of the way. I know some of you are thinking about reflexive, right? But if I go reflexive, is that right angle in the middle of them? No. So they probably still wouldn't be congruent. So anybody got anything else? Ellie, go ahead.
Chord AC and chord AD.
You can go chord AC and chord AD because everyone see their arcs are equal. This is just a good one to have because I'm thinking of we might be able to use every single method here to prove them congruent, including HL. Congruent arcs imply congruent chords. But the way you guys are doing it right now, triangles are congruent by what method? No, just one method right now, based on what we have written down, that you can only use one method. Unless you want to add more, which I don't think we want to. Side, angle, side. Could you add in AB reflexive and then go side, side, side? Yeah, you could. Could you also do HL because they're right triangles? You could. All right, but the way we've done it right now, side, angle, side. Because I didn't mention the reflexive in my proof yet. All right.
That's fine.
Yeah, I marked it, but I didn't write it in my proof yet. So the two triangles congruent by side, angle, side, and then you have CPCTC at the end. All righty. And then you guys can start wherever you want. Okay, start wherever you want.